Students, let's try to understand what is the vector. All the physical quantities can be categorized in the two parts, that is the scalar quantities and the vector quantities. Okay, so all physical quantities means pressure, force, temperature, density, etc. all can be categorized in the two parts. Okay, first is the scalar quantity, and second is the vector quantity. Okay, these two. Now what are the scalar quantities? Scalar quantities means the quantities which have only magnitude. Okay, so which have only magnitude. Okay, and the vector which have magnitude and direction both. Okay, these are the vectors. Now first of all we'll discuss about the scalar which have only magnitudes, which does not depend on the directions, not affected by the direction. See the example. If I take the example mass, distance, volume, speed, pressure, work, charge, current, potential difference, and so many examples. Power also, temperature, specific heat, frequency, etc. Okay, so many examples we have. These physical quantities do not depend on the directions. Okay, do not depend on the direction, only magnitude they have. Okay, now come to the vector which have both, that is the direction and the magnitude both. See the example: position, displacement, force, acceleration, electric field, magnetic field, weight, momentum, impulse, and current density, Okay, there's so many examples again of the vector quantity. See the difference between them. I'm taking the one example. Suppose I say close a door by applying 2 Newton force. So if you are trying to close the door like this, okay, in that case what will happen? If the direction is not given, then you may try to close the door in different directions, and the close will not close. So direction is compulsory. If I ask what is the distance of the Kanpur from the Lucknow, simply you say it is 90 kilometer. Okay, but if I ask what is the position of the Kanpur from the Lucknow, then you have to tell the direction also. 90 kilometer, it is the magnitude, and the directions you have to show in which direction if we move, then we can reach to the Kanpur. Okay, so these are the differences. Try to understand the differences. So vectors depends on the directions as well as magnitude both, and the scalar only depends on the magnitude. Now question arises, how we represents vector. Okay, scalar quantities, suppose if I ask 2 kilometer, 3 kilometer, then 6 kilometer, so it becomes the 11 kilometer. Okay, it becomes the 11 kilometer. But if I ask just add the 2 kilometer north, 3 kilometer south, 6 kilometer east, then what will be the displacement, net displacement? Then you can't add algebraic sum like this. You have to consider the direction also. So to show the direction, we represent vector quantities by arrow. Okay, this tip of the arrow shows the head of this arrow shows the direction, and the length of this arrow shows the magnitude. Okay, shows the magnitude. So you can show in particular direction. Suppose it is in east direction. Suppose you may show the vector of the particular magnitude in, suppose it is in north direction. So you can show the direction as well as the magnitude by the arrow. Now some definitions you must know about the vectors. First I am taking the position vector. Small definitions you have to remember. Position vector. Okay, position vector, I am writing the definition. Try to understand. It gives position. It gives the position of an object with respect to the origin of a coordinate system. Okay, this is the position vector. I am taking the example. Suppose if I take the example here. Okay, so this is the origin, suppose O, and this is the P. So OP, this is the position vector. You can say OP is the position vector if you take this example, because it shows the position of the P from the origin. So this is the position vector. Clear? Now come to the another small definition of the displacement vector. Displacement vector which shows the displacement, how much a physical quantity changed its position. Okay, so you can say it tells how much and in which direction an object has changed its position. Okay, in a given interval of time. In a given interval of time. It tells how much and in which direction an object has changed its position in a given interval of time. So this is the displacement vector. Displacement means, suppose a body, it was the it was the position vector na. So suppose the body shifted from P to Q. Okay, P to Q. So OP is the position vector, OQ is also a position vector, R1 say R2. Okay, and PQ is the you can say displacement, because the body displaces from P to Q. So P to Q is a position, is a displacement vector. Okay, so try to remember the differences between the displacement and the position vector. Now come to the another type of the vector. I'm taking zero vector. See what is the zero vector, useful zero vector. Okay, zero vector means whose magnitude is zero, because vector means the is a magnitude as well as direction. So magnitude is zero and the magnitude is zero and the direction is not specified always. Remember, this is the vector, zero vector. So you can say zero vector is a it is a vector of zero magnitude. Okay, and no specific direction, and no specific direction. Okay, how we represent it? It is represented as zero, like this. Okay, it is zero. How can we find the zero? Suppose A is a vector and the B is also a vector of the same magnitude. If we subtract them, then the resultant will be of scale is a zero vector. Okay, so zero vector means when A is equal to B, then the resultant will be zero. Now see what are the properties of the zero vector. There are few properties. First property, you can say the sum of finite vector and the zero vector is always the finite vector. Okay, there will be no change in the magnitude. Okay, that is the 2 plus 0 is equal to 2. So, and the another if any number is multiplied by the zero vector, then the resultant will be zero vector. Okay, the second property. And third property, you can say if zero vector is multiplied by any finite vector, then the resultant will be a zero vector. Okay, so remember three properties of the zero vectors. Now some more types of the vectors we can discuss. That is the you can say equal vectors. See what is the equal vector. Okay, equal vectors. Equal vectors means two vectors will be equal. Okay, if they have equal vectors which have same magnitude, and same direction, magnitude and direction should be same. Okay, taking the example, suppose this is a vector A. Okay, and suppose this is a vector B. So if the direction and the magnitude, the length and the direction both are same, in that case these vectors are the equal vectors. Okay, these are the equal vectors. And if the magnitude is same but the direction is opposite, so these are called the opposite vectors. Okay, these are the opposite vectors and these are the equal vectors. Okay, So magnitude should be same in both cases. Now question arises how we can add two vectors. How can we add two vectors? So two vectors can be added by triangle method. See what is the triangle method. So next topic is addition of two vectors. How can we add two vectors? Suppose two vectors are given. This is the first vector, say vector A, and the next vector is given vector B, like this. Okay, so how can we add these two vectors? First, you can draw to add any vector. Suppose I am taking the vector A first. You may take the B also first. And now from its head of the first arrow, just join the B. Just remember its direction magnitude should not be changed. Okay, direction will remain same. Okay, it will not change. So now join the second vector from the first vector, like, and then join the initial and the final point, like this. This is okay. So this is the resultant vector, you can say. This is the resultant, which is equal to, you can say, A plus B. This is the addition. Dear students, you can take the second vector first, no problem, and there will be no effect on the resultant. And this is the vector B. You have taken the second vector first, and then you can add the first vector. Just be careful about its direction and magnitude. Now join the initial and the final points of two vectors, and here again the resultant is equal to A plus B. You can see there is no effect on the magnitude. Okay, this length of the arrow will be same, and here also no effect. Okay, you can do like this, you can do like this also. Okay, here you can write R is equal to B plus A, and here it is the R is equal to A plus B, resultant. Okay, so this is the you can say the addition of two vectors, and you can see here the addition of vector is commutative, means A is plus. So here R is equal to, you can say, A plus B is equal to B plus A. That is it is commutative. It is the commutative. Addition of two vectors is commutative. Another method to add the two vectors, it is the parallelogram method. It was the triangle method. It is the triangle method. Okay. Now second method is the parallelogram method. Parallelogram method. Okay, see what is the parallelogram method. Suppose I am taking the same example. Okay, so join two vectors. It is vector B and vector A, like this. Okay, at the same point. It is vector A. It is vector B. Clear? So join at the same point, considering as an origin. Now in next step, what we'll do, draw a parallel line from the B here, parallel line parallel to this, like this, and join and draw the parallel line from here. Why we are doing so? We are making a parallelogram. Okay, parallel, this is a parallel and this is the parallel. Now what we'll do, draw the diagonal. This is the diagonal. Okay, take from the diagonal here only. So this diagonal of this parallelogram is the resultant. R is equal to A plus B. Okay, so this is the parallelogram method. If you see this parallelogram carefully, deeply, then you can see it is basically a triangle method. because here it is the B. You can consider it is the B because it is shifted here. Direction and magnitude is not changed. Here the magnitude and direction both are not changed. So A plus B, it is just like the triangle method. The first vector, second vector, and this is the resultant. So parallelogram method is basically triangle method. So in this way we can add two vectors. Suppose the given vectors are more than 2. Okay, so it is called the polygon method to join the more than 2 vectors. So suppose this is the first vector, this is the second vector, this is the third vector, this is the suppose fourth vector, and this is the suppose fifth vector. Okay, suppose it is vector A, it is vector B, it is vector C, it is vector D, it is vector E. Okay, so you can start to join any vector. You can start from any vector because it is the commutative. It is commutative. Clear? So suppose I am taking the A first. So take A like this. B, join one by one. It is the B. It is, suppose it is C, then it is D, and then it is E. Okay, it is E. So one by one you have joined, and to get the resultant, join the first initial and the final position. Okay, it was the starting, it was the finishing point. So join them, and this is the R. This is the R. Is it clear? This is R. So you can start from any point, and by taking any vector. Suppose I am taking the vector E first, vector E, then take the vector B, D, I am taking the vector C, okay, and then vector B, and then vector A, okay, like this, and then join the initial and the final. So that will be the resultant. So because it is a commutative, you can start from any vector, okay, by taking the any vector. Dear students, these are the simple methods to add the 2 or more than 2 vectors. In next video we'll discuss about some more facts about the addition of vectors. Thank you, students.